All right, great, great, great. Good evening once again, everyone. I trust you're doing well. As announced on our Google Classroom and on our WhatsApp, just as we announced, so far you have made some good progress. Do not call yourself a beginner anymore. You've made some good progress. You started by learning, just a few things on electronics. I believe everyone in here, you remember we mentioned just about ten electronic components that throughout you're working on systems, working on electronic systems. For every product that you're going to find, for a laptop, for a phone, for any product, for these products that exist, you're always going to find these 10 components in there. A resistor, an LED, a capacitor, a transistor, those 10 components that we mentioned. From there, we moved on to we also mentioned after mentioning transistor, we mentioned integrated circuits, right? Integrated circuits. And for integrated circuits, we have microcontrollers, right? We have microcontrollers, and we have those other integrated circuits that do specific tasks, like those integrated circuits that are used for charging batteries, that are used for controlling motors and all of those other components. But for those ones, they are generally, it depends on the system you are building. It depends on what you are using it for. Then you decide to choose it. For example, the battery charging one. So if you're not charging any battery in the system, then you do not need to go for the integrated circuit. But for when you mentioned the integrated circuit, one thing that we took note of really well is microcontroller, right? We also mentioned a microcontroller is an integrated circuit because there's a lot of circuits that have been integrated into a very tiny space, right? And so microcontroller is also an integrated circuit. And then we went into how to program microcontrollers. But even before we went into program microcontrollers, I believe everyone in here, you noted that for microcontrollers we have the power, right? Just like everything, just like everything. As a human being, you cannot do your daily stuff without eating, right? We always need to feed. And so you need to get some food. And apart from human beings, for computers, for phones, for any products, nowadays we have batteries, right? And so you need to supply some power into the battery. No, you need to supply some power into the system. And so just like a TV, you plug it into the your wall socket, or just like your phone, you need a battery inside the phone to turn it on. Just like a keyboard, a wireless keyboard, or any other product, you need some power in it. And when we talked about power, from the basic components that we mentioned, we talked about a battery, and a battery has positive and negative terminals. And then, yes, we need some power going into a microcontroller. And so our microcontroller also needs some terminals, some positive terminals and some negative terminals. And so when you take a look at a microcontroller, when you take a look at a pin out, the pin out, and we mentioned a pin out is just the names of the pins that are on the microcontroller, right? And so you can see ground, you can see VCC, that's the positive terminal. Ground, that's the negative terminal. You can also find the communication pins. If you want two or three, or many microcontrollers or integrated circuits to communicate among one another, right? If you want them to communicate with one another, if you want two to communicate with each other, there needs to be some communication going on. And so we took a look at some communication protocols. We took a look at UART, we took a look at SPI, and we took a look at R squared C, integrated inter-integrated circuit, right? So these are three communication protocols. And across these three communication protocols, we learned that when you want one microcontroller on your right and another microcontroller on your left to communicate with one another, you need to just join some pins, right? It's like two human beings are standing. If they want to greet one and each other, that one person will bring a hand and another will bring another hand, and then they bring it together. So if you want microcontrollers to speak, if you want two microcontrollers to speak with each other, or three or more to speak with one another, then you need to connect their pins together so they communicate. And we learned that for UART, it's just two pins. We have TX, transmit pin on a microcontroller, and receive pin on a microcontroller. So you just have to connect the transmit to receive, and then receive to transmit of the other. So you just just interchange them, and then you write code onto one, and then code onto the other, and then you get them to communicate. From there, we moved on to I squared C communication protocol. For I squared C communication protocol, we learned that you learn that for I squared C communication protocol, it also involves just two pins or two wires. So you just connect this microcontroller's pin to the other, and then this one to the other, and those pins are just SDA and SCL, serial data and serial clock, right? We mentioned that the serial data is just where the data is going to be, flowing, and then the serial clock, just like it sounds in the mentioning of the name, clock. Clock has to deal with time, and so if I'm speaking with someone there needs to be timing. That's the point we're making. There needs to be timing. So one person is going to speak and another person is going to listen, right? And then I'll pause, and then the other person will speak, and then I'll also listen. And so there needs to be some timing between those two microcontrollers, and so that's why we have the serial clock. And so for I2C communication protocol, there's also just two pins: serial data for data, and then serial clock for timing. And then lastly, we took a look at SPI, serial peripheral interface. Just for that one, it's not just two pins; it's 4 pins. So you have one of the pins called MOSI, master out, slave in. You have another pin called MISO, master in, slave out. You have one other pin called serial clock, SCK. This time it's SCK, it's not SCL. For I2T, you have it SCL, but for SPI, it's SCK. And then lastly, you have chip select or slave select. So you just connect those 4 pins from one microcontroller to the other, or to others, and then you have them communicate. So we've learned, you've made some good progress. And then after that, we went into, we mentioned that there are also input output pins on a microcontroller, and those are used for doing the stuff we want to do. And so if you want to have if you want to connect, if here's a microcontroller and you want to connect some sensors to it, you can either you connect those sensors to the input pins. And some microcontrollers have input pins. Those pins can only be used for input, nothing else. And then we have other pins that can be used for both input and output. And then among those other pins, we have some pins that can do just digital. Some pins can do just analog, right? Yeah. And so that was it. We learned about input output pins. So and for input output pins, you can also connect buttons. You can connect sensors to them. You can feed some signal into it, and then you can send some signal out of the microcontroller into other components. So you can connect an LED to the microcontroller, and then you write some instructions, and then say that the microcontroller should send a signal out of it into the component, like an LED, to turn it on or to turn it off, or into a motor to let it rotate or to stop moving, right? Yeah. So those are input output pins. So far you've made some good progress. Right after taking a look at these electronics, and then taking a look at these pins on a microcontroller, we went into the programming. And for programming, you've still made some good progress. You've learned about variables and data types. You've learned about conditional statements, right? We learned that if you want to build a product for people to use, you're obviously going to connect some sensors to it. And when you connect those sensors to it, those sensors are going to be generating data. And so if it's a temperature sensor, if it's just a button that you're going to be receiving on and off signals, those on and off signals, they are data. Those things are data, 1 or 0. It's data. And then temperature sensor, you're going to get something like 25 degrees Celsius, 50 degrees Celsius. These are also data. And so you have to find a way to store those data. And that's the reason why we studied variables and data types. Variables are just containers that will store the data. And in order to create the variable, you need to tell which type of data that variable is going to be storing. And we mentioned that these data, some data may be in terms of words, right? So if a username, if I'm creating an account on Instagram or Facebook, or all of these apps, you need a username. It's the same way if you create a system for the library, for whatever university you are in, usually you have students when they go into the library, they write their name, the time they came in, right? But um, you can design a system where students just come in, they put their thumb on there, and then it registers that they came in at this time, and then they went out at a certain time, right? So all they have to do is just put their thumbs on. But you know that on a university campus there are lots of students, 5,000 students, or so many students, and so you need each student to create a username, right? And to store all of the names of these students, you need to create containers for each of them, for each of the students, and you have to let them type in their names, and a name is full of A, B, C, D, just alphabets or characters, and so you have to store that data, and you need to create a variable, an appropriate variable that can be able to store that data. And to create that variable, you use the string data type, because the string data type can be able to store names, and even sentences, and even paragraphs, right? So you can have on the system, it says please enter your name, right? That is a sentence. Please enter your name. It's a sentence. So you need to store that sentence in a certain variable. And you can do that using the string data type. We looked at storing numbers, like temperature, 24, 25, 26. You need to store those numbers. Sometimes you want to store decimal numbers. So you use a different type of a variable that can be able to store container, that can be able to store that data. And that's the float data type. Because in your system, sometimes you may have certain sensors that do not give you whole numbers, like 20, like 1, like 2. Sometimes some sensors are going to give you something like 20.4, 20.1, 21.2, 4.5, 3.7, like a voltage. We measure, we represent voltage in terms of decimals, right? So you have 4.2. Even if the voltage is 3 volts or 4 volts, you cannot just write 3 volts or 4 volts. You have to say 3.0 volts, 4.0 volts, 3.7 volts. So to record or to store that type of data, I use the float data type. And we also looked at, so data types and variables. You've taken a look at that. And then in our previous sessions, you've taken a look at conditional statement. In a system, you need to do something after reading the data, after getting the sensory data. You need to do something. And so if it's a system like a smart light bulb system that turns on when it's in the evening, and goes off when it's in the afternoon, or it's in the morning, after getting those sensors data, after getting sensory data, you need to make decisions. So you can say that if the sensory data is giving us something like 100, we want you to turn on. If it's giving you something like 0, we want you to turn off, or 1 or 2, we want you to turn off. Right? So you make decisions. And to make decisions, we took a look at two conditional statements. One was if else conditional statement. So you say if the value is equal to this, or if the value is greater than this, or if the value is less than this, we want to do a certain action, right? And then you took a look at that in our previous session. We mentioned that for the if else conditional statement, it's just if or else, right? So it's like, you tell your sister that, hey, if you go to the market and then you find apple, buy it for me. Else, bring my money back. Don't buy anything, right? So it's just two options. If you go and then you find it, buy it for me. Otherwise, just bring my money, right? Yeah. So it's just two options. But we learned a way to just extend the conditions. So to extend it, we use the else if, right? So you say, if you go to the market and you find apple, buy it for me. And then you say, else if you go and then you find mango, buy it for me. And then you say, else if you go and then you find pineapple, still buy it for me. Else if you go and then you still find watermelon, I want you to buy it for me. So you can write multiple conditions, right? Multiple conditions, and then you end with else. Else, just bring my money. So if you go and you find apple, buy it. Mango, buy it. Else if you go and you find watermelon, buy it. Else, don't buy any of them. Just bring my money. So that's it. So simple. Just extending using the else if. So that's the first conditional statement we took a look at. When you want to make decisions in your system, when a user presses a button, you want something to happen. When a user pushes a joystick on a drone system, you want the drone to move forward, right? So you do all of those things using conditional statement. And then the first one It's if else. And then last week we took a look at the second one. The second one is switch case statement. And for switch case conditional statement, we learned that you can just write switch and then you put your value in there where your variables are going to be stored. And then you can write multiple conditions. And then you say that okay, case, you can say case. So that's it's just saying that in case that the number is in case that the sensor value is 5, do this. In case the sensor value is 10, do this. In case the sensor value is 20, do this. In case that the sensor value is 100, do this. So you can write about 50, about 20, about 30, about 70 conditions, right? You can do a whole lot of conditions. You can write a whole lot of conditions, a whole lot of in cases, right? So in case this is the condition, do this. In case this is the condition, do this, right? So that was it. So so far you know how to record your data, your sensory data. If your sensor is going to be giving you numbers, you know how to store it. And after storing your data, you need to make conditions for your system to work so that if a user presses something, something happens. And you take a look at that in our last week's session. But in today's session, we are looking at loops in Arduino programming. What actual what's loops, right? But even before we go into it, for programming microcontrollers, usually like we mentioned, if you go onto a school campus or if you go to the supermarket, you need to know the things that are in the supermarket, right? So when you go to the supermarket, they tell you that if you want to buy clothes, here is the part that they sell clothes. If you want to buy food, if you want to buy groceries, if you want to buy vegetables, here's where you can find vegetables. If you want to buy milk or those other products like Milo, milk, bread, those things, here is where they sell it. If you want to buy spray, cologne, if you want to buy body spray, sure, if you want to buy all of those things, here is where they sell it. So there are different sections in a supermarket. And so it's the same way whenever you want to learn a new skill, you need to not necessarily know everything about it. No, you need to do classification, right? You need to do some classification and know where to find what. And so for programming, some the things the things that are very important for you to know in order to build a product that works. If you want to build a mouse, what are the programming stuff that you need to know to be able to build a mouse? Otherwise, you're going to just continue learning programming. You're just going to learn programming and then you build nothing. You just continue learning programming and then you feel you do not understand so many things and you keep learning, you build nothing, right? So you need to know, you need to classify the things so that you know when you have made progress. So for programming, the things you have to, just for microcontroller programming, if you are using a microcontroller and you're building a product, just about 5 things you need to know, right? And then I believe everyone in here, you saw it on the announcement. Data types, variables and data types, how to store data from sensors, right? And then conditional statements, and loops, right? And we're going to be taking a look at loops. But yeah, for conditional statement, you need to make decisions. And loops, when you want to do certain things like 5 times, 4 times, you use loops. When you want to do something while a condition is true, or we're going to be taking a look at it. But loops are used for repeating things, right? Or what order do you want to do things? Do you want to do this first before you do that? Do you want to do it 5 times? Do you want to do it 6 times? Do you want to do it 10 times? That's what loops are used for. And by the end of today's session, you're going to take a look at it. But yeah, so data types, variables and data types, conditional statement and loops, and what else? What else did we mention in the announcement? I believe someone can take a look at it and share that with us. What did we mention? The things you're supposed to take note of in programming. Let's go on to our announcement. Let's see what we. But if you have it, just unmute and contribute. All right, so I have it here. So variables and data types to store data. And then you have conditional statements, conditional statement and loops. You want to make decisions, you want something to run, how many times, use loops. And then we're going to be taking a look at built-in Arduino functions, right? And when we went into our Arduino IDE, where we write our instructions, where we write our code, you noted that we had been writing some things like serial.begin, some things like pin mode, some things like some things like digital write, digital read, right? We wrote some things like that. These things, there's a classification of them. Some of them are used for time, right? Delay. Some of them are used for timing. Some of them are used for input output stuff. Some of them are used for lots of So you are going to get a classification of these things so that you know where to find what. And we even have some of these keywords or some of these built-in functions that are used for certain things, like when you want to do some math calculation, like square root, all of these things. You're going to take a look at them. But yeah, we have built-in Arduino functions. Whenever you're creating a product and you need to calculate some sensor data. You need to find the square root of one sensor and then divide it by 2, and do all of those things. You can use some of those built-in functions. If you want to read signals, use some of these built-in functions. If you want to read something when a user types in onto the computer, you use a certain functions like you're going to be taking a look at them. But yeah, built-in Arduino functions. And then you're going to learn how to create your own functions, how to write your own functions. But yeah, we're going to be going into it. And then lastly, after taking a look at all of these things, you need to be able to write your own code, write your own functional code. So if you are building a system, if you are building a product, you should be able to write your code from start to finish, how everything is going to work. It's not like, nowadays we have AI, we have AI models, Copilot, ChatGPT, Gemini, all of these AI models, and you can just ask them to write code for you, code that is going to take in code that will ask users to type in their name, and then it will wait for users to type in the name, and then code for a particular system. You just write the words, and then it will generate the code for you. But if you do not understand what the code is doing, it will not really make sense, right? And so that's the reason why you're taking a look at all of these basic stuff, all of these foundational stuff, so that you understand them, so that and how you're going to be getting better is reading other people's code. And when you find someone has written some code that is doing something, you just read through some Arduino code. You just read through, and then you're going to be finding some functions that you've not seen before. You're going to be seeing some structure in which some of these codes are written, and then you're going to learn more. But it's not really necessary, because now you have ChatGPT, you have Copilot, you have Gemini, these AI models. You can just tell it to write you a code that does this using certain functions, or write a very difficult, complex code, and then it will write it for you. And then you find it's not so complex. Because you've learned about these things: data types and variables, conditional statements and loops, built-in Arduino functions. That's it. This is the entirety of code for every system. It's so simple. For Arduino programming, it's so simple. So yeah, you just tell ChatGPT, Copilot, or these AI models, they write it for you, and then you look through, and then you're able to understand. And then but also you need to in a foundational stuff, in a foundational stage right now, you need to be able to learn how to write your own code. If you want something to read something, if you want something to do something, you should be able to write your own code a little bit, right? You need to be able to let the code originate from you. If you want to do something, you're able to write your own code before you go to ChatGPT to write all of these things. But yeah, you're going to get better. So yeah, let's go straight into today's session. In today's session, we're looking at loops in Arduino programming. It's going to be a very short one. All right. So on our presentation, you can see some 3 things in here. When you go down, you can see some 3 things here. For loops, we are taking a look. There are just 3 things we're taking a look at in Arduino programming. We have for loop, we have while loop, and we have do while loop. And I believe for those of you who are studying computer science or computer engineering or electrical and electronics engineering, or these other courses, programming, you've come across these things, but probably you've not appreciated them so well, um in terms of using them to build systems. And so in today's session, you are going to just appreciate them a little bit more. And yeah, let's go into it. Enough of the introduction. Let's go straight into it. Let's go into our Arduino IDE, and yeah, let's make some progress. Let's go off video, and let's go into Arduino IDE. Let's make some progress here. All right, give me a thumbs up once you can see my screen. Once you can see my Arduino IDE, give me a thumbs up once you can see my screen. All right, that's great. That's great. All right, Bernard, Samuel, that's great. Michael, that's great. All right, that's great. Who else? Michael Poti. All right, that's great. Herbert, that's great. Ready from Pon. I believe you're in. All right, that's great. Agnes, I believe you can see my screen. Pius. All right, that's great. All right, let's go into it. Let's take the entire code off and let's make some progress. Let's Control A. Let's take everything off. We have two sections in our code. We have the setup part. So we say void setup, bracket open, bracket close, and then curly bracket open, curly bracket close. All right, that's our setup. And then go to the loop. So void loop, bracket open, bracket close, and then we'll bring our curly bracket open, curly bracket closed. All right. And then we have the upper part here where we can write things that will be seen both in the setup part and the loop part, universal stuff up here. All right. Now let's go into it. Loops. So what at all do we mean when we mention loops? In certain systems, you want to do some things repeatedly, right? You want to do some things repeatedly. And yeah, let's put the topic here. We are looking at loops. All right. And then talking about loops, we have three things. Let's do this. You've also learned this, how to comment, right? If you have a very long comment, you just put forward slash, you put asterisk, and then that's it. You can write a whole lot of things in there, right? So yeah. So our topic is for loops, right? Loops. All right. And then one, we are looking at for loops, right? Two, we are looking at while loop. And then three, we are looking at do while loop. All right, great. All right, that's great. All right, so yeah, that's it. So what are loops? Loops are control structures. When you say control structures, like we mentioned, in a particular system, you would want something to happen 10 times. You want something to happen 5 times, just 5 times, right? You want something to happen 6 times, and we use loops. In certain systems also, you want something to happen until something happens. You want a certain action to happen until something happens before it stops, right? So these are control structures. We use it to control how our product works, how certain things happen in our system. And then yeah, and then in the same system, you want a certain action to happen first before checking whether something is right or wrong. So you want it to run at least once first before it happens. So this may be funny, but there's a simple illustration that can help you understand. So sometimes a police person or an army, right? When we say army, we're looking at these soldiers, right? So a soldier man. Let's use this illustration. A soldier man goes straight to someone who is misbehaving, right? And then in his head or in his mind, he wants to slap the person 5 times. He wants to slap the person 5 times. And so he walks straight to the person, and then he gives the person some slaps. 1, 2, 3, 4, 5. 5 times. That's it. And then he's done. And then he walks away. That's it. So that's the for loop. When a condition, when there's a condition, right? When someone misbehaves, he walks straight to the person. So that's the condition. If the person misbehaves, he walks straight to the person, and then he has in his mind that he's going to give the person 5 slaps. So he knows definitely, right? He knows definitely that he's slapping the person 5 times. Nothing less, nothing more, just 5 times. and then he gives him the slap, the slaps, and then that's it. He walks back. So that's the for loop, right? For for loops, we use it when we want to do some definite stuff or finite stuff, right? When we want to run something 5 times, 10 times, 10 times, 10 times, 11 times. When we know ourselves that we want to do this thing, how many times, right? So if we want to do the thing 10 times, if we want to do the thing 11 times, if we want to do the thing 5 times, the action 2 times, that's when we are definite about what we want to do. So we want to do something finite, right? Right. We have a finite number of times we want to do something, right? So this when we want to do so let's write something here when we know how many times, right? So let's write that here when we know how many times we want to do an action, right? Yeah, when we know how many times we want to do an action or we want an action to run. All right, now that's the for loops. So a soldier man, he only is standing on the street, and then he's waiting for someone to misbehave. Immediately the person misbehaves, immediately the condition is true, and the condition is that if a person misbehaves, so immediately someone misbehaves, and then the condition is true, and then he goes to the person. He knows how many times he's slapping the person. He slaps the person 5 times, 10 times, or 11 times. Definitely, nothing more, nothing less. All right, let's move on to the second type of loop, and that's the while loop. That's the while loop. And how do we use it? For the while loop, just as we are mentioning, while this, we want to do this. While this, we want to do this. And yeah, we're going to be taking a look at it when we go into detail. But yeah, for the while loop, this how it happens. It says that while someone is continuously doing this, or while the condition is continuously true, do it until it becomes false. So that's it. Let's take it again. For while loop, that's how it happens. Continue doing something until the condition becomes false. Then you stop. Let's take that again. For while loop, it says that continue doing something until the condition becomes false. So still with our soldier man, still with our soldier man illustration. A soldier man may just be he may just have in his mind that he'll continuously slap someone. So he's standing in front of this man, and then he continuously slaps the person, and then he tells the person to continue narrating the story. Continue narrating the story, right? He should continue narrating the story. So immediately he hears something out of the person's mouth that changes his mind. Then he stops slapping the person. So let's say at the beginning, the person is saying they are saying a criminal did something wrong, right? Let's say he stole something, right? Allegedly, they are saying that this person stole something. So the soldier man will not even ask. He will not even ask. He'll just go straight to the person and then start slapping, right? He'll start slapping the person. He'll keep slapping the person until after, there are some people, like the instance. I think this is usually used. The instance in a Garden of Eden where God asked Adam, where are you? And then he does not go straight answering the question that I am here or I am there. And then he says, God, I'm blah blah blah, I'm naked, right? And then he's so sometimes when you ask someone, how old are you? They are going to start instead of just giving a number and then saying 2 or 5 years or 10 years, they'll narrate a story. They'll narrate a full story. Okay, they will now start. I was born when this president was, when J.J. Rawlings was ruling, and when the 83 famine came and people were hungry. He will narrate a whole lot of story until he tells you the actual thing, right? So for while loop, the soldier man, he's not going to ask the person, are you the one? Are you the one that stole this? He's not going to ask you anything. He'll just go straight forward and then keep slapping the person. He'll keep running the action until he hears something. You keep running the action, you keep slapping the person until now the person says that after narrating all of his story, then you say, okay, so therefore I did not steal the phone. And then he stops, right? So when the condition is false, then when a condition is false, then he'll stop. So when a condition is true, as long as the condition is true, while the condition is true that the person has not yet stated emphatically or stated, straightforward that I did not steal the thing, he'll keep slapping the person, he'll keep slapping the person, he keeps slapping the person. While the person is still speaking, he'll keep running the action until a condition is false. Then he stops. So that's it. So simple. Yeah. So that's it. And then we have finally we have do while loop. For do while loop, just we have two words in here: do and while. Right? We have do and while. And so this is used. Yeah. Let's put a comment on the while before we do it. So for the while loop, it says keep doing until the condition is false. All right, keep doing until the condition is false. So it will keep doing an action until the condition is false. Then it's going to stop, right? Yeah. And then we have do while loop. Yeah. So for do while loop, we have two words in here. We have do and then we have while. There are two parts. We have the do part, and then we have the while part. This is when you want to do a certain action at least once before you check the condition. You want to do something before you check the condition. And even though we mentioned we're going to be taking a look at it, let's go straight into it. So for a particular system, you may want to ask ask a user, what is your name, right? No, let's go for a better application. Okay, do while do this while this is this. All right, yeah. So it first does an action, right? It first does the action, and then it will come and then look at the condition and then say and then find out whether the condition is true or whether the condition is false. And then it will now ask itself whether it should repeat it or just stop, right? So it will first do an action. It will first do an action before checking the condition, and then he will then decide later whether he's going to keep doing it or stop. So let's still stick to Sojaman illustration. So the Sojaman may just walk straight to this person, and then in his mind he says, I'm going to do this once. I'm going to do this once before I check the condition. So when he walks up straight to the person, he will not even ask the person whether you are the one that stole the phone or did not steal. He'll first give the person a first slap. So first slap, he's not going to ask anything. He's just going to do it, right? That's why we have the do part. So do. He's going to do the action before he's going to check for the condition, right? So he's going to slap the person once. He's going to slap the person once before he will now check the condition. And then after checking the condition, he'll then ask himself, do I repeat it? Do I keep doing it, or do I stop? Right? So that's it. So he walks straight to the person. He does not ask whether you are the one that stole the phone or not. He just gives you a slap. And then after giving you the first slap, then he will ask you, are you the one that stole it or did not steal? So if then later he finds out that you are the one that stole it, then he'll keep slapping you. Otherwise, if you are not the one that stole it, then he's going to stop. So that's the do while loop. He'll first make sure that he does the action once. He does the action first before he checks it. And then after checking, he will then make a decision whether to keep doing it or to stop. So that's it. That's do while loop. So so let's put a comment here. Do it once first, right? So okay, yeah. So first, so he's going to do it once first, and then ask yourself, and then ask whether to keep doing it or stop. Right, so that's it. That's do while loop. So it's just going to go straight into it and then do the first action. After doing the first action, then he's now going to ask whether to keep doing it or to stop. So that's the do while loop. Now let's take them one after the other. This is so simple. Let's take a look at how to write them one after the other. All right, so let's go for the for loop. Like we mentioned, for loop is when you know definitely, you know confidently that I want to do this 5 times, I want to do this 10 times. For example, if you want to turn on an LED for 5 times, you build a drone and you want the light, the red one, to turn on 2 times, you want the green one to turn on 5 times, you want the blue one to turn on, let's say 3 times, right? So you know definitely that you want these LEDs to have to turn on and off 5 times, and then they'll stop, right? So for loop is used when we know how many times we want to do the action. And then apart from that, sometimes in a certain system, you want the sensors, right? You're going to find this, you're going to appreciate this when you're building systems, especially for battery powered systems. These sensors, they consume lots of energy, right? Some sensors, they consume lots of energy. And if you have, let's say, about 30 sensors on a system, and all of these sensors are using energy, right? All of these sensors are using energy. You're going to find that your battery is not going to last long, right? Your battery is not going to last long. So if you have about 5 sensors attached to just a 3.7 volt battery or a 5 volt battery, and you want your system to last for, let's say, a week before the user that purchased it charges it again. So in that regard, you want to write some code. You want the sensor, you want the system to measure the sensory data certain times, right? So let's say at 12 p.m. in the afternoon, I want you to measure, to get the sensory data, right? So that the system does not keep, from morning to evening. The sensor is always drawing current from the system and then wasting energy. So in that particular application, yeah, in a system, if you want to do not waste so much power on your on sensors, and you want the sensor to just measure, you want the system to just get the sensory data just 5 times, or just 3 times, you can use the for loop, right? So that's so simple. All right, let's go into it. Let's go off video and then let's go into Arduino IDE. All right, so let's take a look at the for loop, right? So yeah, let's type in for loop here. All right, we're going to be doing everything in the setup part. All right, so yeah, so for loop, how do we write for loop? So you just write for, right? No, not caps, small letters, and I believe we can see the color has changed. So you just write for, and yeah, to understand for loops, let's get one very simple illustration here, just for loop. All right, so for loop, yeah, so you write your for here, so for, and then you bring your bracket open and bracket close, right? That's where we write our condition. No, that's where we write some things. We write 3 things in here. We write 3 things in here. But yeah, so we write for, and then we bring bracket open, bracket close, and then you bring your curly bracket open and curly bracket close, and then we leave some spaces here, right? Let's take that again. So you just write for, right? You just write for, and then you bring bracket open, bracket close, and then you go out of it, and then you bring curly bracket open and curly bracket closed, right? Yeah, so there's it. That's so simple. I believe everyone is good with the structure for loop. All right, now let's go into it. In a bracket, that's where we do the important thing here, right? In a bracket, remember we mentioned that for loop, we use it when we know how many times we want to do something, right? Yeah, and so let's write something in here. The first thing we write in the bracket here is initialization, right? We need to create a variable, right? So you can say int, b. Int b is equal to int b is equal to 5, we can say something like that. Int b equals 5, and then we bring semicolon. That's the first thing we write, right? Do not worry about this. You're going to appreciate it right after we do it. So the first thing we write in the first thing we write in the bracket is saying something like int b is equal to 5, and that's initialization, right? You create a variable called b, and then you give it a number, right? In the same way, you can say int b equals 0. Usually for most classes you're going to have on learning about loops. Usually they use the letter I for int I equals for int I equals 0, or int I equals 5, or int I equals something. Yeah, but yeah, we are going to be using b for int b. For int b equals 5, right? And then you bring your semicolon. And then the second thing you need to do is you need to write your condition, right? You need to write your condition, right? So let's write something like b int b equals 5, b less than b no b greater than 0, right? That's just something we're writing. Very soon you're going to appreciate this. So yeah, int b greater than 0, and then the third thing you're going to write is whether you're going to increase or decrease, right? Whether you're going to increase counting or you are going to decrease counting, right? Remember, we have mentioned initially that, so this is the initialization. So we say for int b, for b equals 5, right? And then we bring a semicolon. That's the first thing. And then the second thing, we are saying the condition. So for b greater than 0, that's the second thing. And then lastly, we do the increment or decrement. So that's when we're increasing the counting or decreasing the counting. So we can say b plus plus, b plus plus, or we can say b minus minus, right? And I believe some of you in here, you've seen this before. When you say b minus minus, it's nothing. So let's do that in here. So we have two things in here. We have increment, right? Increment and decrement. Increment is when you're increasing, right? It's so simple, just like the word goes. For increment, it's like you're counting 1, 2, 3, 4, 5, right? So 1, 2, 3, 4, 5. You're increasing, right, by a factor of 1 or by a multiple of 1. So you have the first. You can say your first number is 0, and then when you increase 0 by 1, you get 1. When you increase 1 by another 1, you get 2, right? It's like 1 plus 1, 2, and then 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, right? So that's increment. So you're increasing 1, 2, 3, 4, 5. You're increasing. So that's when you say plus plus. So when you say plus plus, right? When you say plus plus, it means it's increasing. So you can have 1, 2, 3, 4, 5, 6, and then it will keep increasing. And then we have decrement. All right. Decrement is minus minus. Just as we know minus 4. Minus means you are just decreasing the thing, right? So if you have 10, it will just decrease, right? So 10, 9, 8, like it's used in the space industry. When you're launching a rocket, they count 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off, and then the rocket launches into space. So that's decrement. So whatever number, so you can say your number is your initial number is 5, and then if you want to decrease this, for decrement, it's going to be 5, 5, 5, 4, 5, 4, 3, 2, 1, right? So that's decrement. So it will just keep decreasing. So if you say your initial number is 7, it will just be 7, and then it will go to 6, it will reduce to 6, and then it goes to 5, and then 4, 3, 2, 1. So that's decrement, and this is increment, right? Yeah, so that's great. These are the two things, increment, decrement. You can choose between them depending on what you are building, right? So yeah, that's the third thing we do in here. So first we say b equals 5, right? And then we write a condition here. We say b greater than 0, or we can say, whatever condition you want to write in here, depending on what you want to do. But we are going to be taking a look at an example. Based on that, you're going to understand this really well. But yeah, and then after writing your condition, that the third thing we write in here, the last thing we write in here is whether increment or decrement. So you can say B should keep increasing, or B should decrease, right? B should decrease. So B, since B is 5, and then you can say B minus minus. If you say B minus minus, then it means B initially was 5, it will now drop to 4, it will now drop to 3, it will again drop to 2, and then drop to 1, right? But if you say B plus plus, if you say B plus plus, then it means B was initially 5, it will now go up to 6, it will go up to 7, go up to 8, 9, 10, and then B will keep increasing. So plus plus, right? I believe increment and decrement is okay. If you are good with increment and decrement, give me a thumbs up, because we're going to be using it in going forward. Give me a thumbs up if increment and decrement is okay. All right, Michael is good. Everyone in here, give me a thumbs up if you are good. Samuel, Roddy, all right, we're good. Agnes, are you good? Bernard, are you good? All right, in team is good. All right, that's good. Herbert, you're good. All right, Pius, are you good? Bernard is good. All right, all right, all right. Then let's proceed. All right, so that's it. For for loops, you have for a for loop, you have three things in here. The first thing, all right, Agnes. The first thing is, I hope you are paying attention. For those of you who when you need to react quickly, everyone pay attention, because this is very, very important. You are going to be working on your project individually, and so please pay attention to this. You're going to be designing your printer circuit board alone. You're going to be writing your code alone. Even if you ask ChatGPT to write it for you, or Copilot, or these AI models to write for you, it's important that you understand whatever it has written for you. If you do not know how it works, you cannot tell it to give you something, right? If you know how the thing works, if it gives you a wrong thing, you know how to correct it, right? And so it's very, very important to understand this. All right. So for loop, like we mentioned, if you want to do something, how many times? If you want to do something for a specific amount of times, you use the for loop. Now let's for these things that we write in here, we're going to be using an example that everyone will understand. But yeah, in the curly bracket open and curly bracket close, this is where we write the actual action we want to perform. So this may be turning on. This may be what should we go for? This may be turn the motor on, right? Turn the motor on. All right. So this may be an action like turn the motor on. So if you want to turn the motor on for 5 times, right? If you want to turn the motor on for 5 times, then yeah, then you use something like this. But now let's take a look at this illustration that will help you understand. So let's take everything off here. Let's take everything off here. But usually, even before we take the things here in the bracket, we've mentioned that here in the bracket there are 3 things, right? We have the first thing here, we have the second thing here in the middle, and then we have the third thing here in the at the right part, right? So the left side, the middle part here, right? And then the right side here, right? These are the 3 things. Good. But usually what I recommend doing is, when you write the first part here, when you write the part on the left, write the part here on the right, right? Write the third thing before you write the condition in the middle. And that is going to really help you, right? That is really going to help you bring some clarity in your own mind. It's going to help you understand better, right? So when you write the first thing, here, when you say B is equal to 5, then write whether B is increasing or whether B is decreasing, right? After writing that, then you come in the middle and then you write your condition. But yeah, let's appreciate these 3 things in here. Let's take everything off. Now, everyone, pay attention to this illustration. Pay a particular attention to this illustration. I want you to imagine. No, I want you to put yourself in your your younger selves into the shoes of your younger self. So just remember when you were just 6 years old, or 7 years old, or 8 years old. At around that age, or 5 years, 5, 6, 7. These kids love playing, right? Children, they love playing. So you are still a child, and And usually children do not are not allowed to go out and play. Children are not really allowed to go out and play, especially when you are not living in a in a in especially when you're living in an estate or these organized communities. So every time children are indoors, right? To go out to play, you need to ask your mom or your dad or your guardian, your parents for permission. So in with this particular one, let's go for your mom, right? So you have a 10-year-old child or a 6-year-old child. He or she wants to go out and play with his friends. But yeah, so that's what we are looking at. Good. So now your mom assume that your mom puts about 5 boxes, right? Depending on how many times your mom wants you to go out, depending on how many times your mom wants to allow you to go out, she's going to put some boxes in a room, right? In a room. So your mom puts 5 boxes in a certain room. And then she gives you a condition that so far as those boxes in that room are greater than 0. So far as the boxes in the room are greater than 0, you can go out to play. So that's it. I want everyone to think about this for a while. So you are a little child, you are 6 years old. Before you go out to play, before you perform any action, you need to ask your mom for permission. And then now your mom wants you to go out, it may be in a month or in a year. She wants you to go out just 5 times, right? She wants you to go out just 5 times in a whole year or in a whole month. So in order to let you go out and then have fun, just go out and then play with your friends 5 times, just 5 times. She knows definitely that she wants you to go out just 5 times. So she'll just put a number of boxes in a room. So she may put about 5 boxes in a room. So that's it. And then she'll give you a condition. She's going to give you a condition, and that's what we write in the middle, right? But yeah, before you go to that, she's going to give you a condition. And then the condition may be that so far as the boxes in a room, right, the number of boxes in a room is greater than 0. And when you say greater than no, so far as those boxes are greater than 0, yeah, I think that's the condition. So when you say um so far as the boxes in there are greater than 0, anything greater than 0 means it's not finished, right? So if it's 0, then it means it's finished. But if it's greater than 0, then it means that there's some in there, right? So you can put your hands in your pocket, right? You can put your hand in your pocket and then try and then find money, right? So if you put your hands in your pocket and you find money, then it means your pocket is not 0. Your pocket is greater than 0, right? So that's the condition. So your mom tells you that so far as the boxes in there is greater than 0, so it means at all point in time there needs to the condition is that the boxes in there is supposed to be greater than 0, so that you can keep having fun. So your mom tells you she puts 5 boxes in a room, and then she tells you that anytime you want to go out, go into that room, pick 1 box, and then bring it to her. And then you can go out and then have fun with your friends. Do whatever you want to do. Just do your action, right? Yeah. So as a child, if you want to go out, you just go to your room. So far as please give me a second. All right, great. Thank you. So your mom puts 5 boxes in a room, and then she tells you that whenever you want to go out, just go to the room, pick 1 box, bring it to her, and then you can go out. Go to the room, pick 1 box, bring it to her, and then you can go out. If those boxes get exhausted. If the boxes in there get finished, so it means um uh it's less than zero. But yeah, if those boxes get finished, then it means you're not going out anymore. So let's say on Monday you go for one box, you bring it to your mom, and then you're able to go out and then have fun with your friends. On Tuesday, you go to the room, you pick one box, you bring it to your mom, and she allows you to go out. But the boxes keep reducing, right? So that's why we have the increment and decrement. So in this particular context, in this particular example, we're looking at decrement, right? So your mom puts 5 boxes in a room, and then she tells you that so far as there is a box in there, you can go out. So far as the boxes in there greater than zero, so far as the number of boxes in there is greater than zero, you can keep going out. So it means indirectly she's telling you that so far as there's a box in the room, you can always bring it and then you go out. But if the boxes get finished, that's if the condition is false, right? The condition she gave you is if the boxes are greater than zero, and greater than zero means that at all point in time there is some boxes in the room. Greater than zero means you have something. Less than zero means, or zero means you don't have anything. If it's greater than zero, then it means at least something exists, right? Yeah, so that's the condition. So far as there are boxes in there, if there are 5 boxes in there, you go for one, it's left with 4. You go for another one, it's left with 3. You go for another one, you're left with 2. Go for one, you're left with just one box. Now, when you go for that one box, the last time you go for it, that's it, it's finished, right? And then you go into the room, and then you find no box, and then that's it, the condition is false. So once the condition is false, you are not allowed to go out anymore, right? So that's it. So always so your mom is going to initialize, she's going to put some boxes in there. And so let's go into Arduino IDE. Let's go off video. Let's go into Arduino IDE. So that's it, that's the first thing you write in a for loop. So in a for loop, you write how many times or how many boxes are in a room, right? So you initialize. So you can say int boxes, right? Int boxes is equal to 5, right? So your mom puts 5 boxes in a room. So she puts 5, and then you bring your semicolon. So that's it. You're done with the first part, right? So int boxes is equal to 5. And then, like I mentioned, there's something you need to write in the middle, but always do the last part, do the last part first, right? Before you come to the middle. So let's do the last part. So let's ask ourselves if we want to increment, if we want to go with increment or decrement. But for this particular one, for this particular example that we gave with a mom, she told her son that if so whenever you want to go out, go for one of the box, bring it. So you are minus. So it's minus minus, right? So if you have 4 boxes, you go for one, left with 4. You go for one, it's left with 3. Go for one, they're left with just 2, right? So this one is decrement. So all we are going to say is boxes minus minus. Oops, boxes no, boxes minus minus. All right, so that's it. So simple. And then you come in the middle here, and at this part here, we don't bring any semicolon, right? We don't bring anything like, yeah. For the increment and decrement, you don't bring any semicolon. All right. And then in the middle, that's where you write your condition. This is where you write your condition. So let's write that the mom's condition. The mom is saying that so far as the boxes, so far as the boxes are greater than the number of boxes are greater than the number of boxes are greater than 0. So far as the number of boxes are greater than 0, so let's write boxes greater than boxes greater than 0, right? So that's the condition, and then you bring your semicolon. We are all good. So let's again do this. So your mom puts 5 boxes in a room, and then she tells you that so far as the boxes are greater, the number of boxes are greater than 0, those boxes will be reducing, right? Those boxes will be reducing, right? So that's what your mom is telling you. She tells you, hey, I put 5 boxes in a room. Now those boxes, I want you to, anytime you want to go out, anytime you want to perform an action in a for loop, anytime you want to go out with your friends and then play, I want you to first go into the room and then check how many boxes are in there, right? Just check how many boxes are in there, right? And then those boxes, even though she put 5 boxes in a room, she wants you to go and then you pick one every time and then bring it. So you are just subtracting. Every time you go, you pick one and then you bring it to her. So those boxes will keep reducing, right? So that's it. Boxes minus minus. And then in the middle, she tells you the condition. And then she tells you that, okay, I put 5 boxes in there. Every time you want to go out, you go and then bring me one. So you are subtracted. Good. And then she tells you the condition that so far as those boxes, the number of boxes in there are greater than 0, you can always bring me one and then go out with your friends and then do whatever action you want to perform in your system, whatever action you want to do. So the main thing you have to understand is the condition. So far as the boxes are greater than 0, and greater than 0 means that she's directly telling you that if the boxes are so far as the boxes are greater than 0, keep subtracting, keep going in there and then taking the boxes. So that's it. So far as the boxes are greater than 0, keep going into the room and then keep subtracting, keep going and then taking a box, right? So that's it. So let's so that's it. I believe we're all good. Okay, Bernard, I believe you've gotten something, but yeah, you're going to appreciate this once we go forward. But up until this point, give me a thumbs up if you are good. Bernard, you mentioned you are good. Ready from Michael? All right, Michael is good. Herbert is good. Samuel is good. All right, all right, all right. That's good. That's good. All right. So yeah, for for loops, that's when you know how many times you want to perform an action. So yeah, now let's examine the for loops and then let's see how many times the action we have run the action in here is going to run. The action is we want to turn the motor on, right? That's those are the action. And in our example, that's when the mother is telling the child to go out, right? Go out and play, right? That's it. So go out and play. That's the action you want to, how many, that's the action you want to perform. So, but before we know how many times this particular action is going to perform, we need to analyze the thing here in the bracket. So we are saying 5. So the initial boxes is equal to 5, right? And the initial variable here is equal to 5. And let's take boxes off. Let's use B. So now I believe everyone is good. Let's use B. Now we're using the word B. Good for simplicity. So instead of using boxes, we're going to be using B. And yeah, we can use any alphabet. Usually they use I. Usually so many people use I when they are learning loops or for loops. All right. So we are saying for int b equals 5. For int b equals 5, we are going to be decreasing the value of b. We are going to keep decreasing the value of b. And then we are saying the condition is if b is greater than 0. So we are going to keep decreasing b so far as b is greater than 0. So far as there's a number in b, so far as there's 1 in b, we are going to decrease. So far as there is 2 in b, we're going to be decreasing. So far as b is equal to 5, so far as b is equal to 4, so far as b is equal to 3, so far as b is equal to 1, so far as b is greater than 0, right? We are going to be decreasing, right? So that's the condition, right? So that's it. So b's initial value is 5. So for the first time that the child goes in there, he counts the boxes. So he counts 1, 2, 3, 4, 5. All right. And then he says that, okay, yeah, the condition is true because b is greater than 0. The boxes are 5 and 5 is greater than 0, right? So he can just pick one. He can just do b minus minus, right? He can just pick one of the boxes out. So he subtracts one of the boxes, b minus minus. All right. So he takes one of the boxes out, and then now, and then he goes to his mother, right? And then shows the box to his mother, and then he can go out and then do all of the action in here. He can perform the action once, right? And then after doing it, the next day, now when he goes in there, b is not equal to 5 again. B is no more equal to 5. B has reduced to 4, right? B has reduced to 4. B was initially 5, right? So we initialized it here. We said int b is equal to 5. right? The boxes are equal to 5. And then we said on the first day, he goes in there, he takes one of the boxes. Now B is equal to 4. Good. So we're going to have the action run first. So when 5, so let's write something here. So when when B is equal to 5, right? So to know how many times the actions are going to be running, whenever the condition is true, the action is going to run, right? So when B is equal to 5, on the boxes, let's do this. When boxes is equal to 5, right? The action runs for the first time. So action runs. So let's write something here. Let's say action runs, yeah, action runs, right? Yeah, so that's it. So that's it. All right. And then now on the next day, B is no more 5. B has now reduced to 4 because we are saying B minus minus, right? So B will now reduce to 4. So let's write that here. Now we now B after when B reduces to 4, so now boxes is equal to 4. Now we need to ask, no, boxes is equal to 4. Good. So now we need to ask ourselves, is 4 greater than 0? So now let's write 4 here. Is 4 greater than 0? Let's get reactions from us. Is 4 greater than 0? Someone should unmute and tell us. Okay, I see Michael, you say yes. Michael, please unmute. Is B greater than is 4 greater than 0?
Yes, please.
Yes, so 4 is greater than 0. So it means the condition is still true, right? Yeah, so when boxes is equal to 4, we will still run the action. So action runs. All right, so all of the action that we write in here is going to run. Good. Now, B is still doing minus minus. B is still reducing, right? So now we are going to have a time where the child is going to go into the room and then he's going to count the boxes in there and then he'll count 1, 2, 3, right? So when boxes is equal to 3, right? Let's ask ourselves. So now we go to the condition and then we say, is B greater than 0? Is 3 greater than 0? Who is going to answer that? Is 3 greater than 0? Herbert, is three great? Okay, Bernard, I see you have a hand raised. Bernard, is 3 greater than 0?
Yes, sir.
Yes, so it means the condition is true. The condition that B is greater than 0 is true. All right. So once the condition is true, so B is now B was initially 5. So we compared 5 to 0. We compared B to 0. B which was initially 5. So we said 5 is 5 greater than 0, and then the answer was yes. So the action runs. All right, and then after that the number of boxes reduces from 5 to 4. Now we need to ask ourselves again, is B greater than 0? Is 4 greater than 0? Yes, 4 is greater than 0, and so the action is going to run again. The child can go out and then have fun with his friends. So yeah, action runs. Yeah, and then from 4, yeah, it moves to 3. And then we ask ourselves again, is B greater than 0? Is 3 greater than 0? If the answer is yes, then the action is going to run again. So far as that condition there is true, the action will keep running. Now let's ask ourselves, when B reduces to 2, so when boxes is equal to 2, right? Because our decrement here keeps decreasing the value. It keeps decreasing the value from 10, 9, from whatever value it is, it will keep reducing. So now, yeah, our B was initially 5, it decreased to 4, it decreased to 3, it now has decreased to 2. So now let's ask ourselves again, is 2 greater than 0? Is B greater than 0? Is 2 greater than 0? Who's answering that? Herbert, is 2 greater than 0?
Yes, please.
Yes, 2 is greater than 0. So since 2 is greater than 0, the action is going to run. All right, so the action runs again. All right, and then now 2 is now going to reduce to 1, right? So when boxes reduces to 1, right? When the box reduces to 1, now let's ask ourselves if the action is going to run or not. So is B greater than 0? Now we have B equals 1, right? We have B equals 1 here. So is 1 greater than 0? Who's answering that? Michael, you've already answered. Herbert, you've already answered. Bernard, you've already answered. Let's go for Roddy. Roddy, is 1 greater than 0? Is 1 greater than 0? All right. Okay, let's move on to the next person. Samuel is one greater than zero. Samuel is one greater than zero.
Yes, sir. One is greater than zero.
All right. So yeah, since one is greater than zero, it means it's true. It's true that b is greater than zero, and b is just one. All right. So since b is one and one is greater than zero, the action is going to run. So if the child goes into the room and then she finds there were five boxes, now it's left with one. Still, he has hope because he knows that so far as b is greater than zero, he can keep coming for a box, right? He can keep coming for a box and then going out. So he checks the box, and then this time on Friday he checks them. He checks them. He goes to the room, checks the box and the number of boxes, and then he finds just one box left. He still has hope because one is greater than zero, and so when boxes is equal to one, the action will still run. All right. So action still runs. All right. So now, from 1, the value will keep decreasing because we are still saying b minus minus. So b was 5, it moved to 4, it decreased to 3, it decreased to 2, it has decreased to 1. Now let's ask ourselves, if b reduces from 1 to 0, now let's ask ourselves if the condition is true. So let's write something here. Let's say when boxes is equal to 0, will the action run or will the action not run? So in for this particular one, for this particular instance, or for in this particular, at this particular time, b is equal to 0, right? B is equal to 0. Now we need to ask ourselves, is 0 greater than 0? Is 0 greater than 0? Okay. Yeah, Michael Putti, thumbs down. All right, that's great. But let's get everyone's contribution. Samuel, is 0 greater than 0? Is 0 greater than 0? Herbert is greater than I mean is 0 greater than 0? All right. Bernard is saying no. Herbert is saying no. All right. So 0 is clearly not greater than 0. So it's just 1. 1 is greater than 0. 2 is greater than 0. 3 is greater than 0. So far as we keep getting those numbers, our condition is true. But if the boxes reduces to 0, the child cannot go out because the condition is now false. The condition is now false. The condition is that so far as b is greater than 0, now we have b equals 0, and 0 is not greater than 0, so the condition is false. So if the condition is false, then no action is going to run. The child can no more go out. He goes to the room, he finds no boxes, and then he remembers the condition his mom told him. His mom told him, hey, if you go inside the room and then you find that the boxes are greater than 0, so every time there is a box in there, you're going to go out. But if there are no boxes in there, then you're not going to go out. So it's as simple as that. So it means for the last time, the loop is going to check whether b is greater than 0. It found that b is equal to 0, and that was false. So now let's take that out, and now let's ask ourselves how many times. No, I think let's bring that in here, and then let's write what happens. So action does not run. The action is not going to run because the condition is false. B is not b is less than 0. I mean b 0 is not greater than 0. So the action is false. All right. So now let's ask ourselves. Let's count how many times the action run. So we have 1 here. The action run 1 here. It run 2 here. 3 on the third time. On the fourth time. On no on the fifth time. It ran on the fifth time, right? So yeah, that's it. So when it checked the box, it's we said for int b equals 5, we are decreasing b minus minus, right? Good. So if b is 5, it will keep decreasing. If b is 10, it will keep decreasing. All right. And then we say we put the condition here. We say so far as b is greater than 0, keep decreasing. Keep decreasing b, right? So we say for int b equals 5, So far as b is greater than 0, keep decreasing until b is no more greater than 0. Then you stop. So that's it. 4, 4, 4. So that's it. 4 int b equals 5. So far as b is greater than 0, we want you to keep decreasing until the condition becomes false. Then don't decrease anymore, right? So that's it. So far as b is 5, at the initial part we said b is equal to 5. So since b is equal to 5, the condition is true. B, which is 5, 5 is greater than 0, and so the action we write in here is going to run. Good. So it's going to run for the first time. Good. So the child can be able to, the boy can be able to go out with his friends and play. So far as the boxes in there were 5. Good. And then on the next day, he takes one out. On the next day, he goes, he finds 4 boxes. And then he asks again, is 4 greater than 0? Is 4 greater than 0? Yes, 4 is greater than 0. And so he can do the action again. The action can run on the second time. Good. And then the boxes will reduce to from 4 to 3, because we are saying b minus minus. So it's still decreasing every time we take one out. All right. Now the boxes is 3. So now b is equal to 3. So when b is equal to 3, let's ask ourselves, will the action run? Is the condition true or false? All right. So we ask ourselves, is 3 greater than 0? Is b, which is now 3, is 3 greater than 0? Yes, 3 is greater than 0. And so the action is going to run again on the third time. So the action is going to run on the third time. The child can go out and play with his friends. All right. And then the number will decrease again and then go to 2. Now, is 2 greater than 0? Yes, 2 is greater than 0. And so now the action is going to run on the 4th time again. So every time the condition is true, every time b is greater than 0, the action is going to run. Every time 2 is greater than 0, the action is going to run. Unless the action becomes false, right? That's when the condition is not going to run. So yeah, and then it reduces all the way from 5 to 1. So so b is now equal to 1. So we ask ourselves again, is b greater than 0? Is 1 greater than 0? Yes, 1 is greater than 0. 1 is indeed greater than 0. And so the action is going to run again, right? The action is going to run on the 5th time, right? And then lastly, b is now going to reduce from 1 to 0. Now we ask ourselves, is b, which is 0, is 0 greater than 0? No. The action is the condition is now false. So if the condition is false, then we are not doing the action here. The action is b minus minus, right? The increment, the decrement here is b. What we are doing here, the command we are doing here is b minus minus. That's the command, right? Is b minus minus. So if we have b, an initial value of 5, we are saying, hey, the command is we are decreasing, right? So that's it. So so yeah, to summarize everything, the actions are going to run 5 times. So when you want a sensor to check its values 5 times to save your battery, right? Just 5 times in a day. You should check its its environment just 5 times to save the day. So no, I mean to save its power. So in the morning, you should check just 5 times. You want the sensor to just check 5 times. So you just have to write the action in here. In order to do that, you need to pay attention to what you do in a bracket in here. So first you do so first you write. So we say 4. Let's write that again. We say 4, right? 4. Bring our bracket open. And then you write your initial value, right? So initialization, your initial value, right? Initial value. Good. After your initial value, you write the condition, whether the condition. So you can say, so far as b is greater than 0, or so far as b is less than, 0, or just the condition. So you write your condition, right? After your value, you bring your semicolon, and you write your condition. After writing your condition, you also you again bring your semicolon. Then after you write your command. Your command is whether you're incrementing or you're decrementing, whether you're increasing the number or you're decreasing the number, right? So if you give your initial value of 5 and you want to increment, you want to increase. So if you give your initial value a number of 5, it will keep increasing. 5, 6, 7, 8, 9, 10. If you say decrement, it's going to decrease from 5, 4, 3, 2, 1, in that order. All right. So that's the command. So the command is whether increasing or decreasing, whether plus plus or minus minus. So that's the command. So that's it. And then after, just put your curly bracket open and curly bracket close, and that's where we write our action. So the action may be reading a census data, right? So read. So you can say read sensory, read sensor, yeah, read sensor data, right? Yeah, read sensor data, and the actual reading of the sensor data may be maybe you can create a variable like int, right? Int distance, int distance is equal to analog read. No, let's use voltage, because usually voltage for those sensors, they are analog. So we say int voltage, right? So you're keeping track of your voltage in your system. So we say int voltage is equal to analog read, right? Analog read. You write the action analog read, and then you bring your bracket open, bracket close, and then you put your pin where you have connected your voltage sensor to on your microcontroller. So you can just say pin A1, right? Yeah, pin A1. That's what we connected our sensor to. That's it. So it's so simple. So it's going to read, right? It's going to read the sensor value. All right, so that's it. So it's going to read the sensor value, and let's say we want to read the sensor value 10 times. We want to read the sensor value 10 times. So let's do that practically now. So let's initialize a value. Let's initialize the value. So our initial value, let's say we'll go for int, right? We say int x, right? Int x is equal to 10, right? Int x is equal to 10. And then what's our condition, or what's our command? Let's do our command first. Like we mentioned, our command is we are decrement. So we say int no x minus minus, right? So our x initially had a value of 10. Since we are saying the command is decrement, x minus minus will be decreasing. So from 10, 9, 8, in that order. All right. So our command is x minus minus. And then let's write our condition. And our condition is what is going to tell whether the action is going to run how many times. So if we want the action, let's go for a condition where we want the action to run 10 times. So if we want the action to run 10 times, we can say so far as x, right? So far as x is greater than 0. So far as x is greater than 0, that's our condition. So now let's analyze. So far as x is greater than 0. So it means when x is 10, the action is going to run on the first time. Good. And x will now reduce to 9. So far as 9 is greater than 0. So the action is going to run again. So the second time. And then x will reduce to 8. So 8, when x is equal to 8, the action is going to run. And then so on the third time. And then when x is equal to when x is equal to 7, the condition is true. The action is going to run again. When x is equal to 6, the condition is true. So 6 is greater than 0, right? Yeah. So the action is going to run again. So it ran on the what was it? Was it the sixth? Was it the fourth time? Yeah. When x is equal to 6, it's going to run on the fourth time. All right. And then 6 is going to reduce. X, which was equal to 6, will now reduce to 5. Big. And then so when x is equal to 5, still the condition is true. The loop is going to run again. The for loop is going. The actions in there are going to run again. All right. And then when x is equal to 4, the condition is still true, and it will run again. When x is equal to 3, the condition is true. It will run again. When x is equal to 3, the condition is true. It will run again. It will keep decreasing. When x becomes equal to 1, the condition is still true. Which the condition is x greater than. So far as x is greater than 0, we want to keep decreasing the value, right? Yeah. So when x is equal to 1, 1 is greater than 0. So the action is going to run again on the ninth, on the 10th time, right? And then when the one decreases to now 0, when x is equal to 0, is 0 greater than 0? No, the condition is false, and then it stops, right? So when we want to run the action 10 times, we write a condition saying that x is greater than 0. We're saying so far as x is greater than 0, we want to keep doing the actions that we've run there. All right. But ask yourself, ask yourself, if you want the sensor to print, if you want your system to read the sensory data just 5 times, but you said x is equal to 10, right? You just initialize your value to say x is equal to 10. It does not matter what you have initialized. You can do you can write your condition in such a way that it was still the action it was still there are still going to be 5 possible outcomes, right? There are still going to be 5 times the condition is true, so that the actions in there are going to run. So let's do that. If you want the action, if you want the action to run 5 times, what do? Even though you have x is equal to 10, someone should come up with a condition. So I'm going to do the first one. The first one is let's go for 5. Let's see. Let's just go for 5, and let's count how many times the condition is going to true. The condition is going to be true. All right. So initially x is equal to 10, right? And we are decrementing. X's value is always decreasing, right? Yeah. So initially x was equal to 10, right? So but yeah, let's take a look at the condition again. We are saying so far as x is greater than 5. So far as x is greater than 5, we want to keep decreasing x, right? So it means if x becomes equal to 5, then it's going to stop the command of decreasing. I believe that's good. We're saying int x is equal to 10. X initial value is 10. X is initially 10. And then we're saying that, hey, so far as x is equal x is so far as x is greater than 5, we want you to keep subtracting. It's like you have a friend, and this friend always likes eating from your chop box. You know, old in the days where we're in a high school. You know, your chop box. Or yeah, you can have about just five sardines, right? So you can have about 10 sardines, and then you give them a condition that, hey, so far as the sardine is greater than 5, you can keep taking some. You can keep decreasing. You can keep x minus minus, right? You can keep minusing from it. You can keep subtracting from it. Every time you go and an x is greater than 5, you can keep taking. So it means the last part, I mean the last situation where he can take is when x is equal to 6. When there are 6 sardines. So when there are 6 sardines, then it means 6 is greater than 5, right? It means x is not the sardine. So we can write sardines in here. So far as the sardines are greater than 5, you can keep taking. So the last time you can keep taking is when the sardines are 6. 6. So 6, when you compare 6, right? When you compare 6 to 7, I mean 6 to 5. So between 6 and 5, which one is greater? Is 6 greater than 5? Yes, 6 is greater than 5. So that's the last time that the condition is going to be true for him to keep taking from it. But when now the x reduces to 5, now 5 is not greater than 5. In fact, 5 is equal to 5, right? 5 is not greater than 5. So the condition becomes false. So when he goes to your chalk box, and then now he finds that there are 5 sardines, then he knows that the condition is now false. So he cannot take any more sardines, right? He cannot keep subtracting. He cannot keep doing the command here. So yeah, so now let's try and then see how many times this action is going to run. So for the first time, we have x equals 10. Is 10 greater than 5? That's the question. Is 10 greater than 5? Who's answering? Michael Opuchi, I believe you want to answer. Is 10 greater than 5?
Yes, please.
Yes. So when x when x equals 10, the condition is true, so it's going to run. So run. All right. And then now from 10, x is going to reduce to 9. So is 9 greater than 5? Is 9 greater than 5? So when when x equals 9. Okay, I see we have a hand raised. Please go ahead. When x equals 9, well, the action one is 9 greater than 5. Samuel? Yes, Samuel. Go ahead, Samuel. Okay, I believe you may have a system issue, but Herbert, you can go ahead. Anyone can pretty much go ahead. Herbert, Agnes, Rodi. Okay, Bernard, let's go. When x becomes equal to 9, when x becomes equal to 9, is 9 greater than 5?
Yes, sir.
Yes, so the action is going to run. So when x becomes 9, the action is going to run. And then now when x becomes equal to 8, so after running the action, it will just decrease the value by 1. Every time it goes and then picks a sardine, the number is going to decrease. Every time the child goes into the room and then finds and then takes a box, yeah, it's going to reduce. All right, so when x is equal to 8, it's going to run. All right, going to run. All right, and then now x will reduce to 7, right? X will reduce to 7. So when x is equal to 7, now let's compare. Is 7 greater than 5? Herbert, is 7 greater than 5? All right, 7 is greater than 5. So yeah, it's now going to run again when x is equal to 7. All right, and then when x is equal to 6, x will reduce now to 6. When x is equal to 6, will the action run? Is the condition true? Is 6 greater than 5? Yes, yes, 6 is greater than 5, so it's going to run. All right, and then lastly, when x when x is equal to 5, when x is equal to 5, will the action run? First, is the condition true? Is 5 greater than 5? No, 5 is not greater than 5. So not run. So let's separate not run. All right. Let's separate run. Let's separate the yeah when x is equal to 5. All right. So yeah, we can see that we had 5 times. So this was the first time, right? This was the first time. When x was 10, it was the first time. When x was 9, it was the second time. When x was 8, was the third time. When x was 7, it was the fourth time the action ran because the condition was true. And then when x reduced to 6, that was the fifth time the condition was true. And so the action ran. So yeah, now we can see that the action ran 5 times. So you can always play around. You can always for how many times you want an action to be done, you can just initialize the value, write your condition, and then you write your command, whether increasing or decreasing. And yeah, I believe everyone is good. If you are good so far with for loop, give me a thumbs up. Give me a thumbs up if you are good so far with for loop. All right, Herbert is good. Bernard, you are good. All right. Michael Opoti, I believe you're good. Agnes, Roddy, I believe you're all good. All right. Now, our time is fast spent, but you must achieve your goal of joining today's session. You want to learn loops, and for loops you have three kinds: for loop, while loop, and do while loop. And so yeah, let's do that quickly. Let's take the for loop part off. Let's take this off. Okay, yeah, let's take everything off. Let's take everything off. And now, oops, undo. Let's take the for loop examples off. And then now let's take a look at while loop, right? While loop, so simple. For while loop, like we mentioned, for while loop, it's going to keep doing it until the condition is false. So it's not like the for loop where you have a definite times that you want to do an action, right? If you want to do an action 5 times, no. For while loop, so far as the condition is true, it will keep doing forever until the condition becomes false. Then it's going to stop. So that's while loop. So while the condition is true, it's going to keep doing. It's going to keep doing until the condition becomes false. So an example can be in a particular system that you have built. Um, in a particular system that you have built, you want uh you want um you want the system to keep asking the user for a name, right? until you want the system to keep no. That's not a good example. Let's go for an example like yeah, for a system that you have a button, right? You have a button on the system, like on a phone, or yeah, on a system. You have a button on a system that a user can press, right? So until the user has pressed it and then the condition has become false, um keep doing something, right? So you can say keep turning the red light on until the user presses the button before you stop turning the light off, right? So while the user has not pressed the button, we want you to turn the red light on, give him an alert, like the when an alert system is happening, right? So the red light will keep turning on and turning off, keep turning on and then turning off until the user presses the button, right? So while the button keeps being not pressed, the red light will keep turning on until the user presses the button. Then the condition will become false, and then he or she and then the action stops, right? So we can say while, right? While, and then we bring our bracket open, bracket close, and then we go out of it, and then we bring our curly bracket open and curly bracket close, and that's where we write our action. So our action may be yeah, so let's write our condition in here. So for the while loop, we only write the condition in there. We do not write all of those initialization condition and the command, whether increment or decrement. No, for while loop, we only write the condition in here. So we write condition, right? Yeah, so let's write a condition. So we can say that while the button is giving us a signal of 00000, we want you to keep turning the red light on until the condition becomes false. And the condition becomes false when the user presses the button. And when the user presses the button, the signal is no more going to be given 0. The signal is now going to be given 1 into the system, right? Yeah. So we say while button is equal to 0. While button is equal to 0, that's it. That's it. Yeah, and then you bring I do not know. I'm not sure you're going to bring a semicolon. Are you going to be bringing a semicolon? Yeah, I think you're going to be bringing a semicolon. Okay, let's confirm that quickly in here. Let's go on to Copilot, right? Let's go into Copilot. What is a loop? All right, let's type in what is a loop, and let's type in what is a loop, and then let's go into search. All right, and then now let's take a look at Copilot and let's see. So that's it. If you know what you are doing, if you know about all of these things, whenever you need to clarify on something, if you're writing a code and then you're not getting something really right, you can just use these AI models and then you figure it out, and then you do the clarification. I think one of these, as we're waiting for my tab to show, one of these scientists, I think Albert Einstein or Rutherford or one of these scientists, I think he mentioned that um uh, something that you can look up to, that there's no need storing that in your mind, right? Something that you can always, it's like you have a calculator or you have a chart that has a multiplication timetable, 2 multiplied by 2, 2 multiplied by 5, so far as you have it, and the problem you are solving is just within that particular frame. There's no need storing some huge stuff in your head. No, because you always have it. You always have to go to it and then refer to it, right? Yeah. So yeah, in here, let's ask Copilot how. Okay, let's see. Okay, right. Yeah, let's see. Right. Let's type it in here. I believe we all can see. Yeah. So let's see. Write a while loop. Write a while loop in Arduino. Oops. In Arduino programming. All right, and enter. Let's see what it's going to give us. Okay, so okay, all right. So it's saying while condition code should be executed. All right. So yeah, an example is while count is less than 5. Yeah. So there's nothing like bringing a semicolon. Yeah, there's nothing like bringing a semicolon for a while loop. All right. So yeah, let's go back into Arduino IDE. Let's quickly finish this and then bring session 2 to a close. All right, I believe this should pop up in just a second. Once you see my Arduino, give me a thumbs up. Give me a thumbs up once you see my Arduino IDE. Okay, are we all right? Great. So yeah, we're not going to bring anything in here. We just write the condition, right? So yeah, let's take this off. Let's start. While bracket open, bracket close. We bring our bracket our curly bracket open, curly bracket close, and then in the while here we write that condition. Good. And then let's take a practical example. A practical example is when we write while, bring our bracket open, bracket closed, and then we bring our curly bracket open, curly bracket closed, and then in here, and a practical example is when we say button, right? We know that our button can give us signals, two signals. On, it's going to be giving us one signal values of one or values of 0, 0, 0, 0, 0. So while the button is equal to right? So we put two equal to signs here, and this is I think, yeah, there's a comparison operator. So just as we can say greater than, if the button is greater than, if the button is equal to, but this time we don't say, we just don't bring one equal to. That will be an assignment operator, right? That will be an assignment operator. That will mean we are assigning a value to it. But if you want to do a comparison, if you want to ask whether a button is equal to something or greater than something, just like how we do it, you use two equal to signs. So you do equal to, right? Equal to. So while button is equal to 0, while it's given us values of 0, 0, 0, we want to do a certain action here, right? We want to turn an LED on. So we want to turn a red LED on. All right, and that particular action may be in a form of saying digital, right? Digital, let's not put a comment there. That action may be in a form of saying digital, right? Digital, right? And then you see the pin number where your LED has been connected to. So let's assume you connected your LED to pin 6, right? To pin 6, and then you bring your comma and then you say hi, right? Hi. And then that means you've written a certain action on it, right? You've written a hi on it. All right. So you turn LED on. All right. But yeah, so that's it. But for the button here, right? For the button here, you need to create the button up there first. You need to create a variable first, right? So you can say button, you can say int button or byte button, but let's just use int. Int button is equal to int button is equal to digital read, right? So first you have to say digital, you have to read the signals before you can, after getting the data, you now make your decisions, right? So just remember that you need to do that. So int button is equal to digital read, and let's say you're reading from, connected your button to pin, let's say pin 2 or pin 3, right? And then yeah, you'll be receiving the button signals using the action digital read. So you say digital read digital signals from pin 3, and then you're going to store those signals, those 0 and 1, right? Those 0, 0, 0, 1, 1, 1, depending on when the button has been pressed or when the button has not been pressed. And yeah, those values are going to be stored in a variable called button that we have created here. So at any point in time, there are going to be just two values, right? So button can be given as 0, button can be given as 1. And then we say while the button is equal to 0, while the button is given as 0, we want to perform this action. So this action is going to run forever until the condition here becomes false. So until a user has pressed the button to generate a signal of 1, the action is going to keep running. This action here, it's going to keep running forever. So that's why when you learn about while loops in programming in school, you're going to hear something like this runs forever, right? But it does not really run forever. It stops when the condition is false, right? So that's it. So while the button is equal to 0, We want you to keep turning the red light on and off. Blink the red light to tell the user that, hey, you've not pressed the button yet. So when the user presses the button, it now generates a signal of 1. And then now it comes back and it says, okay, is button equal to 0? Is the condition true or false? So when the condition becomes 1, then it says, okay, now the condition is false. And then the following action happens, right? The following action happens. So the action may be, the action may be now turning the green light on, right? So now you can see digital, right? Down there, you can now see digital right, green LED, high. And then you turn the green LED on, right? That's it. But yeah, so that's the while loop. So for while loop, it's going to run forever until the condition is false. So far as the condition is true, it's going to run forever until the condition is false, and then it stops. All right, so that's while loop. Now let's take a look at the last type of loop, and that's do while loop. Today's time is way over, but yeah, let's do that quickly. Do while loop. For do while loop, like we mentioned, for do while loop, it's going to make sure that it does the action first before it checks the condition to see whether it's true or false. So you have the soldier man. The soldier man is not going to ask any question. He's just going to walk straight to the person, and then he's going to slap the person once. He's going to give the person the first slap before he listens to the story, whether you tell him you stole the phone or not. So whether you stole it or you didn't steal it, he does not care. He's going to give you the first slap before he now asks you, did you steal the phone? If you say yes, he will then continue slapping you. So that's the wow. So do that, he's going to slap you, and then he will now ask whether you stole it or not. So in a while, in a second part where it says wow, it will now ask whether it's you stole or not. So if you didn't steal, then he's going to stop, right? If you didn't steal, then he's going to stop. But if you stole it, then he's going to keep slapping you. He's going to repeat the action that he did up there. So first, he's going to do it. He's going to slap you, and then he'll ask you for the condition, whether you stole it or not. And then, depending on the answer you give him, then he's going to decide whether he's going to repeat it or he's going to stop. So that's the do while loop. So we say do. So for the do, we say do, right? I believe you can see the color has changed, and I will put bracket open, bracket close there, and then we bring our curly bracket open, curly bracket close, right? So that's the do part, right? Do, and then while, and then we say while, right? While. Well, let's take a look at the syntax. I may be getting ahead of myself. I may be I may be this may be escaping me, but yeah, let's go into the syntax, and let's take a look at the syntax in from Copilot. Yeah, let's go into Copilot. I believe everyone can see Copilot. Let's give it just a second. All right, good. So let's ask Copilot, write a do while loop. Write a do while loop. All right. So this is just how you build a system. Once you understand how these things work, whenever, okay, it's written JavaScript. Okay, yeah. So that's it. Yeah. So that's it. Okay. So it says do, right? Do, and then it brings the bracket open, bracket close. No. Do. No. Oh, come on. Why did we miss this? So it says do, and then it brings curly bracket open, curly bracket close. It writes the action in there, and then now it asks wow, and then you bring the bracket open, bracket close, and you write a condition in there. So simple. All right, now let's go back. Let's go back into Arduino IDE. Let's go back into Arduino IDE. Let's finish this up. Our time is far spent. Okay. All right. I believe you'll be able to see my screen in just a second. All right, big. All right. So now let's do the do while loop. So we don't write do and do the curly bracket. No. That's not a syntax. We say do, and then do what? The action, right? And whenever you want to write an action, you do curly bracket open and curly bracket close, right? So yeah, we bring our curly bracket open and curly bracket close here, and that's where we write our actions. And then we write while, right? And then we write while, right? You write while right after it, right? While. So while, and then you write the condition in there, and then you bring your semicolon, right? I believe that that was simple. So you do what? So you do your action, do your action, do your action in here, and then now after doing the action at least once, you do the action first, and then you come ask the you come to the while part and you say wow, and then you write the condition in here. So let's go for, let's take an example, right? So we say do no, do curly bracket open, curly bracket close. What action do we want to do? Let's say we want to turn a light on before we check the condition, right? So we can turn the light on by saying digital. Let's put a comment here. Turn light on. All right, and then let's put the actual code here. Digital right, digital right. Pin 5, pin 5 high, and that's when we are turning the LED. That's when we are turning the LED on. All right, yeah. So yeah, so we are turning the LED on. So this is the action we want to do. So it will first do the action, right? It will first turn the light on, and then now it's going to ask wow, right? Now it's going to say wow, 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 button, wow, button. The signal we're getting from the button is equal to the signal we're getting from the button, or let's say sensor, right? Sensor, sensor reading, right? Sensor reading is equal to 500, right? Yeah. So we are assuming that we have a sensor attached to our system. We want a certain action to get done. We want a certain action to get done. Want to do a certain action at least once before checking the condition, right? So we are going to do turning the light on, and then now we'll come to while sensor reading is equal to 500. And a practical example can be we're not going to be writing it. A practical example can be doing a checkup, or doing a routine checkup, right? Sometimes for a system, you would want to check whether the IMU, the initial measurement unit, is working right, whether the servos have been connected, whether the GPS module has been connected, whether the all of the sensors have been connected, right? Before 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 the system, the entire system turns on, right? So it says do. So you just write do, and then you write all of the code that is going to be checking your entire sensors here, right? And you write all of the code that is going to be checking the entire sensors here, and then you say wow, let's say power button has been pressed, right? I think that's not a good example. Let's go for a better example. It checks everything while Bluetooth has been connected, right? While Bluetooth has been connected. So while so yeah, so you can just write something here like this. Yeah. So a very practical example is when it's going to check all of the accelerometers. So for a particular system that you have built, right? Immediately the user turns it on, it's going to check whether the sensors are working correctly. It's going to check whether the actuators have been connected. Everything is connected, right? It's going to check. And then after doing all of the checks, then it will check whether the phone or the device has connected to Bluetooth, right? The device has connected via Bluetooth to your phone or any other device, right? So it's going to do the checkups, right? It's going to do the routine checkups while Bluetooth is connected successfully. So it's going to first do the checkup at least once, right? And then after checking the condition here and then seeing that Bluetooth has connected, then it decides whether it's going to continue working, or it should just stop, right? Yeah. So that's it. I believe you have made some good progress. In today's session, we took a look at loops. For loops, when you know the definite amount of times you want to do an action, whether 5 times or 10 times, when you know it. While loop is when you want the action to keep running. So far as the condition is true, you want the action to keep running until it becomes false. It should keep running forever. Immediately it becomes false, then the action stops. And then finally, do while loop. You do the action first. You do the action first, and then you come now to check the condition. After checking the condition is true, then you can keep repeating. Otherwise, you stop, right? So the soldier man just slaps the person first, even before listening to the story. And then when a person tells and then depending on and then after he asks the person, after asking the person, depending on what the person tells him, whether the condition is true or false, then he can decide whether to proceed or to stop. All right, now we bring today's session to a close. I believe you have made progress. If you're good, yeah, our time is fast spent, but our recording is going to, our session is going to be recorded, and we're going to be posting that on our YouTube database. And yeah, for all of you who were able to stick around, but if you're able to stick around, that's great. I believe you've made some good progress. For loop, while loop, and do while loop. I believe everything is good. Give me a thumbs up, Michael. Herbert, if you're good so far. All right, Michael is good. Herbert, I believe you're also good. All right, all right. Then on this note, let's bring today's session to a close. Everyone, have a very good night. We're going to be connecting God willing tomorrow, Sunday, for what are we going to be taking a look at? We discuss for loops. In tomorrow's session, we're going to be taking a look at built-in Arduino functions. And yeah, you're going to make some good progress. All right. On that note, have a good night. We're going to be connecting God willing tomorrow. Bye. Bye everyone. Bye.